Welcome to aminacademy.com. In astronomy, let us do introduction. Astronomy is the study of everything in the universe beyond Earth's atmosphere. That includes objects we can see with our naked eye, like the sun, the moon, the planet, and the stars, etc. We gather information about the cosmos from the messages that universe sends our way. Because the stars are the fundamental building blocks of the universe, decoding the messages of starlight has been a central challenge and theme of modern astronomy. By the time you have finished reading this, you visited this video, you will know a bit about how to read that messages and how to understand what it is telling us. Next, we'll talk about the nature of astronomy. Astronomy is defined as the study of the object that lies beyond our planet Earth and the processes by which these objects interact with one another. We will see, though, that it is much more. It is also humanity's attempt to organize what we learn into a clear history of the universe from the instant of its birth in the Big Bang to the present moment. Astronomy is defined as the study of the objects that lie beyond our planet, Earth, and the processes by which these objects interact with one another. We will see, though, that it is much more. It is also humanity's attempt to organize what we learn into a clear history of the universe. In considering the history of the universe, we will see again and again that the cosmos evolves. It changes in profound way over long periods of time. For example, the universe made the carbon, the calcium, and the oxygen necessary to construct something as interesting and complicated as you. Today, many billions of years later, the universe has evolved into a more hospitable place for life. Tracing the evolutionary process that continued to shape the universe is one of the most important and satisfying parts of modern astronomy. The nature of science. What is the nature of science? The science is a distinctive way of gaining knowledge about the nature world that tries to answer questions using evidence and logic. Scientists assume that nature can be understood through systematic study. Scientific ideas are open to revision. Sound scientific ideas withstand a test of time. The ultimate judge in science is always that nature itself reveals based on observations, experiments, models, and testing. Science is not merely a body of knowledge, but a method by which we attempt to understand nature and how it behaves. That means science is not merely a body of knowledge, but it gives the method by which we attempt to understand nature and how it behaves. That means what? Regarding our knowledge, the science enlarges to us. That means what? We are getting some knowledge. From that knowledge, we develop more about nature of the science. As a concrete astronomical example, ancient astronomers construct a model that is partly from observations and partly from philosophical beliefs. That Earth was the center of the universe and everything moved around it in a circular orbit. It's ancient thinking. At first, our available observations of the sun, moon, and planets did fit this model. However, after further observations, the model had to be updated by adding circles after circle to represent the movement of the planets around Earth at the center. As the centuries passed, the improved instruments were developed for keeping track of objects in the sky. When they are first proposed, new models or ideas are sometimes called hypotheses. What is hypothesis? You may think there can be now hypothesis in a science such as astronomy that everything important has already been learned. Nothing could be further from the truth. Throughout these videos, we'll discuss more about astronomy. A hypothesis must be a proposed explanation that can be tested. So it is a proposed explanation that can be tested in various ways. The most straightforward approach to much testing in science is to perform an experiment. If the experiment is conducted properly, its results either will agree with the predictions of the hypothesis or they will contradict it. If the experimental result is truly inconsistent with the hypothesis, a scientist must discard the hypothesis and try to develop an alternative. If the experimental result agrees with predictions, this does not necessarily prove that the hypothesis is absolutely correct. Perhaps later experimental will contradict crucial parts of the hypothesis. That means hypothesis always be tested. But the more experiments that agree with the hypothesis, that more likely we are to accept the hypothesis as a useful description of nature. One way to think about this is consider a scientist who was born and lives on an island, for example, where only black ships live. Suppose a scientist lived only in Iceland. He is not familiar with other land in the history at that time. What happened? He may think only black ships live. Day after day, the scientist encounters black ships only, so he or she hypothesizes that all ships are black. He may think in the world all ships are black, but although every observed ship adds confidence to the theory, the scientist only has to visit the mainland, that means other land of the Iceland, that what happened, and observe one white ship to prove the hypothesis is wrong. What is the hypothesis? The lived thinks ships are only black, but the suppose if we see a white ship in other world, we can say we can disprove that hypothesis, that is ships are always black. When you read about experiments, you probably have a mental picture of a scientist in a laboratory conducting tests or taking careful measurements. This is certainly the case for a biologist or a chemist, but what can astronomers do when the laboratory is the universe? It's impossible to put a group of stars into a test tube or to order another comet from a scientist supply company. As a result, astronomy is sometimes called the observational science. We often make our test by observing many samples of the kinds of object we want to study and noting carefully how different samples vary. New instruments and technology can let us look at astronomical objects from new perspectives and in greater detail. Our hypotheses are then judged in the light of this new information, and they pass or fail in the same way we would evaluate the result of laboratory experiment. Next one, the laws of nature. Laws of nature in the philosophy of science is stated regularity in the relations or order of phenomena in the world that holds under a stipulated set of conditions, either universally or in a stated proportion of instances. Over centuries, scientists have contracted various scientific laws from countless observations, hypotheses, and experiments. These scientific law are, in a sense, the rules of the game that nature plays. Our remarkable discovery about nature, one that underlies everything you will read about, understand from this video, is that the same laws apply everywhere in the universe. The rules that determine the motion of the stars so far away that your eye cannot see them are the same laws that determines the arc of the baseball after batter has it is out of the park. That means what? We can compare it. One important problem in describing scientific models has to do with the limitations of language. When we try to describe complex phenomena in everyday terms, the words themselves may not be adequate to do the job. For example, you may have heard the structure of the atom likened to a miniature solar system, while some aspects of our modern model of the atom do remind us the planetary orbits. Many other of its aspects are fundamentally different. This problem is the reason scientists often prefer to describe their models using equations rather than the words. We avoid complex math, but if this course piques your interest and you go on in science, more and more of your studies will involve the precise language of mathematics. So far, we discussed shortly about the nature of law of nature, the nature of science, and nature of astronomy. These all together some introduction about the astronomy. In further videos, we will go details about astronomical studies. We have done. Please subscribe our YouTube channel.